Chapter 11, SIR Model, Part 1. If you return to our previous section, we had an expression like this: new cases per day is equal to, this is just a constant, times a number susceptible times a number infected. Didn't look exactly like this. This is just a C value that I gave you. Well, this whole expression right here is that C. And the difference with this model is now we have recoveries to worry about with the logistic growth equation. Once infected, always infected. Now we're going to siphon off a certain number of the recoveries. This Greek letter tau is actually the infectious period. R naught is the basic reproduction number as before. These variables here, S of 0 is the initial number of susceptibles, I of 0, initial number of infected, R of 0, initial number recovered. This is actually the total population here. So, but of course, these individual variables can change, but this is always the total population here. You can work this out dimensionally and it works out fine. So, for instance, just to put some numbers, if tau is equal to 5, for instance, then basically 1/5 of the infectables recover every day. If we had 10 people infected and tau was 5, we would expect 2 people to recover in any given day. So we're going to add this to our algorithm. This is part 1 of the model. We're just going to work through getting used to what these variables are. And then part 2, we'll actually build the model. I'll show you how it works. First thing to think of is these are coefficients we can calculate. This is going to be replaced by a number. This is going to be replaced by a number. So we do those calculations prior to working out the model. In this situation, we have a population of 500 people. 10 are infected. Tau is 5 days. R naught is 2.3. And unless otherwise specified, we'll assume there's none recovered. So we're going to start at the beginning of our calculation. Well, first of all, we're going to calculate this coefficient, R naught over tau, S of 0 plus I of 0 plus R of 0 is going to be, that is 2.3 divided by 5 times, you can calculate these. In this case, 10 are infected, 490 are susceptible, 0 are recovered. But you can just add that in here, 500. That's 2.3 divided by 2,500, works out to be 0.00092. Okay, keep track of that coefficient, that's pretty important. We'll use that in the next video. We also want to calculate this coefficient right here. That's pretty easy. 1 over tau is 1 over 5, which is 0.2. And likewise, we're going to use that. If you're wondering at this point why we skipped from chapter 7 to 11, we have enough information to build the model. Chapters 8 through 10, I'll go through that later. That might perhaps help you understand where this coefficient comes from. But for now, we're going to just use this coefficient as it stands. So, okay, that's the end of part 1. It's a short video. We'll be back with part 2 shortly.